Hello and welcome to this lesson in quantitative reasoning. We're going to look at Venn diagrams. We're in the unit on sets. This is the first of two videos that goes through what Venn diagrams with two sets looks like and how you use a Venn diagram. It's actually a Venn diagram is the graph of a set. In math, there's four ways we look at math. One of them is with our words. One of them is with lists of numbers called numerically. Another one is with equations, algebraically, you might think of that. And another one is graphically, visually. Venn diagrams are the graphs we use for sets. So let's take a look at our notes here. And we're going to split this video into two parts. In this first part, we're going to talk about right here, listing the universal set, the complement of set using a diagram. And then we'll get into two Venn diagrams and set notation, the Venn diagrams for two sets and notation. So this is a way to visualize sets. When you see a graph, it is a visualization of something having to do with math, typically, or it has to do with other things. Venn diagrams are actually used to visualize all kinds of things, and you've probably seen them before. There have been some memes floating around on social media that talk about, you can believe all three of these things are true and showing it's the intersection of three sets. And there have been some other funny ones going around from time to time. But a Venn diagram, basically, if it's just one set, you'll see it's one circle. It's circles. And what you write in those circles is either how many things are in the set or list the things that are in the set. We're mostly going to start with listing things in the set. So first you draw a rectangle. You get a big rectangle. And the rectangle represents the universal set. Everything you're dealing with in the problem will show up somewhere on this rectangle. Anything that could possibly be chosen to work with in the problem must appear somewhere. It might not appear inside a circle, but it has to appear in this rectangle. Think of your rectangle as your piece of paper. And then there are several other things involved in Venn diagram. We're going to walk through them. I don't want to confuse it by getting ahead of myself here. All right. So this is a Venn diagram, and some of you are thinking, well, that doesn't look that familiar. It is still a Venn diagram. It is a way to depict a set. What's true about set A and set B in this diagram is that they are what we call disjoint. The fact that they're completely separate circles and there's no overlap means they have no intersection. Nothing in set A also occurs in set B, and nothing in set B occurs in set A. The gray rectangle is our universal set. That's all the numbers we would be talking about. So an example, if we were talking about the numbers 1 through 15, and I'm going to say U is the numbers 1 through 15. And 1, 2, comma, dot, 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 15. And let's say set A was the even numbers less than 5. A would be 2, comma 4, and set B was the odd numbers less than 16. You'd have 1, 3, 5, 7. You wouldn't actually put the commas in necessarily. 9, 11, 13, 15. I said less than 16. So set B has all those. Notice, there's nothing in A is in B, so this is fine. But I'm missing some pieces of the universal set. I've got 1, 2, 3, 4, 5 covered, but I don't have 6, so that's a mistake. Again, I don't need the commas. I can write a 6, I can write an 8, a 10, a 12, and a 14. The point is that somewhere in this rectangle, every element of the universal set is represented. I can count 1, 2, 3, 4, 5 is here, 6 is here, 7 is here, 8 is here. All 15 elements occur in the box. The ones inside of B are in set B. So B is the set, if we write it in roster form, 1, 3, 5, 7, 9, 11, 13, 15. That's everything in circle B. And set A is the set containing 2, 4. I already wrote our universal set up the top. It's the counting numbers through 15, including 15. So every one of those numbers, 1 through 15, has to show up once and only once. That will become important when we do have overlaps on this rectangle. And that so the number 1, you can't write the number 1 outside here because it belongs to set B, so it has to go inside set B. So that's a basic look at how you would organize information about a set using a Venn diagram. In this case, our set is disjoint, so we don't need to show an overlap. You'll see that you can still show the circles overlapping and just not put anything in the overlap, and that'll also mean they are disjoint. So, it's a way to visualize sets. The set is represented by a circle and drawn inside a rectangle. It represents the universal set. What we just saw was a disjoint set. No intersection, no overlap, no intersection. The intersection is contained in an overlap of the two circles, and there is not one. So there's not any elements that you find in both sets. A and B are completely different areas. So they do not overlap. It means there is no intersection. And we'll get talking about intersections and unions within the context of these Venn diagrams also. So that's what I've been saying. A and B have no elements in common. They're disjoint. So an example of this would be, here's another example. This is not the one I did. If A is 1, 2, 10, and B is 3, 5, 9, 15, you can see that there's nothing in A that's also in B. They're both subsets of a universal set of numbers, but we don't have any elements in common. The complement of a set. There's a bunch of ways to write the complement of a set. Our book tends to use a superscript C. I have also seen, in the other book I used to use, they use a single quote. I have also seen that. There are maybe a couple other ways even, but mostly we're going to be sticking with this one. So a complement is everything not in set A. So if you have a picture of set A, this purple area is set A, the lightly shaded area outside, including set B, anything outside of the circle for A is the complement of A. So out here, all of this is the complement of A. I like to scribble, can you tell? But it's everything outside of A, still inside of U. So the stuff out here is in U, but it's not in A. That means not A. So what happens when we do have overlapping sets? Well, that's usually the way you see a Venn diagram. You draw the generic Venn diagram, a two-set Venn diagram. You draw with two circles, and you provide an overlap just in case the two sets do have things in common. So if there is things written in this overlap here, if I write the element 1 and the element 2 there, it means 1 and 2 are in set A and also in set B. And you can see that if I trace the circle for set B, I do go around the 1 and the 2. If I trace the circle for set A, I go around the 1 and 2. So that's all there. It's in both sets. That's called the intersection. So they have another example here with A is 1, 2, 10, B is 3, 5, 9, 10. If I draw a circle for set A and another circle with an overlap for set B, my circles aren't great, but you'll get the idea. So 1 is an A, 2 is an A. The 10, I look for the things that are the same. I have a 10 in each of them. I write that in here first. And now the rest of set A is not in set B, so I could write a 1 and a 2 out here. And then the set B, 3, 5, and 9 are here. And anything missing from the universal set would be written out here. But the overlap, you identify the intersection, write that first. You do not write that 10 twice. When you're through drawing a Venn diagram, the elements in the set, just like in sets, you don't list something twice in a set. If 10 occurs twice, you only list it once. So for a Venn diagram, when you're done, every element appears once and only once. You can't write the 10 over here in A and also over here in B. So this is a nice one with colors. So A and B are subsets of the universal set, which is this rectangle, and they have one element in common, the number 10. That number 10 is going to go in the green space. The green space represents A intersect B. That's the overlap. This symbol is for intersection. And they kind of have like an N there, but it's also like a staple where they're stapled together, where the things are put together. Now, you're going to need to know this symbol means intersection, and there's another one that looks like a U called union. You're going to need to know that also. So, overlapping sets, you would put the 10 there. Things that are in A but not in B are there. The things that are in B but not in A are there. And things that aren't in either A or B are out here in this universal set part. Okay, so we have 3 sets shown here. X, Y, Z. Now, I said we were working with 2 sets, but this is just asking you some vocabulary stuff here. What of the following statements is true? They're going to ask us about them having an intersection and being disjoint. So I see X. X is disjoint from both Z and from Y. X is completely disjoint from those two. Z and Y are not disjoint. They have an overlap here, so they have some piece in common. You don't even know, the sets don't need to be discrete pieces. This is just showing you the shaded area. This whole shaded area is set Z. This whole shaded area on the paper is set Y, and they have some area in common, so they have this intersection. Let's see what our answer choices are here. So we notice X is by itself, Z and Y have some overlap. So Y is not disjoint because it overlaps with Z. So I can't pick this answer. X and Y are disjoint sets. Only X is a disjoint set. Well, I guess X and Y are disjoint. I'm going to take that back. Sorry. They're talking about individually. Let's go back to our picture. X is disjoint from both Z and X is disjoint from Y. And I said that and I answered that wrong. So X is disjoint from Y. X is disjoint from Z. But Y and Z have an overlap, so this is not true. So I can't pick A. X and Y are disjoint. X and Z are disjoint. Y and Z are overlapping sets. That is true. That's probably our answer, but I'm going to check answer C just in case. X and Y are overlapping. No, X, if I look back at my picture, X did not overlap, so that's wrong. So my choice must be B. These statements about that picture are all true. X and Y are disjoint. They have no piece in common. X and Z are disjoint. They have no piece in common. Z and Y are overlapping. There is an intersection. So we would pick B. And this goes through the definition. They give you an example here. I just want you to get the vocabulary about disjoint and intersection down. So this time I have C is disjoint from A, C is disjoint from B, A intersects B. Sets A and B are disjoint. Oh, we want to know, is set C the complement of A? So how would I do the complement of A? Well, to do the complement of A, I'm going to put a red circle around A. I'm going to outline, there's A. Everything in this circle is A. C is not the complement of A. All this other stuff outside of A, that is the complement of A. So C is the complement of A is not true. Sets B and C are disjoint. That's true. There's no overlap between B and C. Set C is the complement of A. Set B, no, you need more than that because you also need that universal set. Just A is true here. Even though you can say, well, set C is not in A. That's true. There's no overlap with C and A, but it doesn't mean C is the complement. The complement is much bigger than that. It's everything that's not in A. Even if it's in B, the stuff in here would be in the complement of A also. So you would pick only A there. They're disjoint, and it does not mean it's the complement. All right, so that's where I want to stop with this video and pick up in part 2, and we'll talk about some more about Venn diagrams with 2 sets. Thank you for joining me.